Imagine a space so vast it defies comprehension. In this space there is no air, no sound, no light, just emptiness. Is it truly possible for such a thing as absolute nothingness to exist? Or perhaps the cosmos, in its boundless complexity, does not allow for true voids? The vacuum is one of the most fascinating phenomena in the universe. It appears to be nothing, yet it holds secrets capable of reshaping our understanding of reality. Why does anything exist at all instead of simply not existing? This question has haunted philosophers, scientists, and even dreamers gazing into the night sky. Today, we delve into one of the universe's most intriguing phenomena, the vacuum. From ancient philosophers pondering whether nothing could even exist, through the experiments with Magdeburg hemispheres that revealed the power hidden within a vacuum, to modern studies of quantum fluctuations and dark energy that seem to steer the fate of the cosmos, what appears to be nothing is, in reality, the foundation of everything. Ready to uncover the secrets of this elusive mystery? Let's start from the beginning. Did you know that people once feared nothing? Quite literally. The ancient Greeks believed that nature abhorred a vacuum so much that it wouldn't allow one to exist. They called this concept horror vacui, or fear of emptiness. This idea was so deeply ingrained that for centuries no one dared to challenge it. Aristotle, one of the greatest minds of antiquity, also believed that a vacuum was impossible. According to him, nature would always find a way to fill emptiness with water, air, or something else. And as for motion, Aristotle thought that in a vacuum, an object wouldn't know which way to move, as it would lack any points of reference. Sounds logical, right? But is it really? For centuries, these ideas were treated as indisputable truth. Imagine how much this must have stifled human imagination. If a vacuum didn't exist, why bother searching for it? Eventually, however, some brave individuals decided to test whether Aristotle might have been wrong. It was these trailblazers who opened the door to some of the most important discoveries in the history of science. But how did they do it? How did they convince the world that a vacuum exists? Let's move now to a 17th century marketplace in Magdeburg, Germany. A crowd gathers around a large square. At the center are two massive metal hemispheres gleaming in the sunlight, with a group of scientists in elegant attire preparing their equipment. All eyes are fixed on the scene. What is about to happen? Enter Otto von Guericke, the mayor of Magdeburg and a scientist who first demonstrated that a vacuum truly exists. He joined the hemispheres, removed the air inside and waited. Now came the ultimate test. Was the atmosphere strong enough to hold the hemispheres together? It took 16 horses pulling in opposite directions to separate them. Imagine the scene. The horses straining, the spectators holding their breath, and yet the hemispheres remained inseparable. Atmospheric pressure was the real star of the show. But that's not all. At the same time in Italy, another scientist, Evangelista Torricelli, was conducting his own experiments. Torricelli took a glass tube, filled it with mercury, sealed one end, and inverted it into a container of mercury. What happened? The mercury in the tube dropped, leaving a vacuum at the top. A simple experiment, but one of monumental significance. It proved the existence of atmospheric pressure and showed that it could be measured. These experiments were like opening the doors to a new scientific era. Thanks to Guericke and Torricelli, we began to understand that a vacuum not only exists but can be studied. To onlookers in the marketplace, it might have seemed like a clever trick, but for science, it was a groundbreaking revelation. So what happened next? How much did our understanding of the universe change? After the spectacular experiments with the Magdeburg hemispheres and Torricelli's tube, scientists began asking deeper questions about the vacuum. What is it really? This led to two groundbreaking ideas. Newton's view of the vacuum and the concept of the ether. Let's start with Newton. To him, the vacuum was like a stage where the grand theatre of the universe played out. It was an empty space where planets, stars, and all objects moved. Newton saw the vacuum as the domain of gravity, a force that pulls objects toward each other over vast distances. But for many people of his time, this was almost impossible to believe. How could a force act at a distance without any visible connection? This is where the ether came in. Scientists imagined it as an invisible substance filling all of space. There was no emptiness because ether was everywhere, even in places that seemed void. It was thought to be the medium through which light traveled and electromagnetic waves propagated. The problem? The ether needed to have bizarre properties. It had to be invisible and undetectable, yet rigid enough to carry waves of light at enormous frequencies. Doesn't that sound like scientific sorcery? Here's a fascinating tidbit. For nearly 200 years, the ether was considered an unquestionable fact in science. Everyone believed in it, even though no one could see or measure it. Some of the greatest minds in history tried to find evidence of its existence. It was like a ghost, simultaneously explaining everything and proving nothing. Then came Albert Einstein. His theory of special relativity shattered the concept of ether. It turned out that light didn't need any medium. It could travel through empty space. For scientists, this was a true revolution. Something that had been considered a cornerstone of physics suddenly ceased to exist. It's like being told that the Earth isn't round after all. When I think about this, I am in awe of those who dared to challenge what seemed undeniable. Imagine a scientist saying, "Hey, the entire world believes in something that doesn't exist." It's thanks to people like that that physics became what it is today. A relentless pursuit of truth, even if it means dismantling old beliefs. But what happened next? What did we discover when we looked at the vacuum through the lens of quantum mechanics? That's where the real madness begins, transforming everything we thought we knew about the universe. Now let's consider empty space, a place where there isn't a single atom, no light, no sound, nothing. It seems like the ultimate definition of a vacuum, right? But here's where quantum mechanics works its magic. It turns out that the void is not empty at all. On the contrary, it's the most dynamic place you can imagine. Quantum mechanics introduced a concept that defies common sense: quantum fluctuations. Simply put, even in absolute emptiness, things are happening all the time. Pairs of particles and antiparticles pop into existence from nothing, only to annihilate each other moments later. It's as if the universe is playing a continuous game of creation and destruction, and we can only see the final outcome. What's most fascinating is that these virtual particles, though fleeting, have real effects. Consider the Casimir effect. If you place two metal plates very close together in a vacuum, a mysterious force pulls them together. Why? Because the virtual particles that exist everywhere can't fit between the plates as easily as they can outside. This phenomenon is proof that the vacuum is teeming with invisible activity. But quantum fluctuations aren't just a curiosity. Here's something even more mind-blowing. Some scientists believe that our entire universe might have originated from such a fluctuation. Think about it. Everything you see, stars, planets, galaxies, you and me, could have started as a fleeting impulse in this seemingly empty space. To me, this is the pinnacle of magic. Quantum mechanics shows that our reality is far more complex than we can imagine. The vacuum isn't dead, static, or boring. It's a place where particles emerge and vanish, where energy trembles on the edge of existence, and where even nothing can create something. When I ponder this, I feel like we're part of an extraordinary puzzle. The universe is full of mysteries, and we're still uncovering how deep they go. But this isn't the end. Quantum mechanics is just the beginning. The vacuum holds an even greater mystery: dark energy. Now we see that the vacuum, this dynamic quantum cauldron, is not just a place where particles appear and vanish. It's something much more. Something that not only fills space but governs the entire universe. Meet dark energy, the greatest enigma of modern cosmology. Let's start with a mind-boggling fact. Over 70% of the universe is made up of dark energy. Not atoms, not planets, not stars. Everything we see, the entire ordinary universe, is just a small crumb. The rest is something invisible, elusive, yet incredibly powerful. But what is this dark energy? It's responsible for the accelerating expansion of the universe. Imagine it pushing everything away from everything else, like an invisible force pulling the strings of the cosmic theater. It's as if the universe has a built-in engine that defies intuition and the laws of gravity as we know them. Here's the astonishing part. Albert Einstein thought of something similar over a century ago. He called it the cosmological constant, a term he added to his equations to make the universe work mathematically. Later, he dismissed it as the biggest blunder of his life. But modern scientists have proven he was right. Dark energy behaves much like that constant, a mysterious force acting throughout the cosmos, though we don't yet understand its origin or workings. Now imagine another thought experiment, a universe that slows down, stops expanding, and then begins to contract. All matter, energy, and space collapse back into a single point, the Big Crunch. This could have been an alternative future were it not for dark energy. Like a cosmic break, it prevents this scenario. Dark energy shows that the vacuum is not merely empty space. It's an invisible web of tension stretching and shaping the entire cosmos. Within this emptiness lies the potential to create everything. The thought that something so intangible could drive the entire universe always leaves me in awe. When I look at the night sky, I'm reminded of how little we know. In the vast expanse of stars, planets, and galaxies, the greatest mysteries are hidden where there seems to be nothing. And what if that's where our journey began? Perhaps it's the vacuum with its dark energy that was the origin of everything. But what does this all mean for us? Is dark energy the key to understanding our place in the cosmos? Or is it just a glimpse of even greater mysteries to come? We could talk about this for hours, but for now, I'll leave you with this thought. The vacuum, though invisible, is more real and powerful than we could ever imagine. The vacuum. At first it seemed simple, emptiness, the absence of anything. But the deeper we look, the more we realize it's one of the greatest wonders of the universe. From ancient philosophers who feared the very idea of nothing, through experiments proving that the vacuum exists, to modern discoveries of quantum fluctuations and dark energy, the vacuum has proven far more complex than anyone could have imagined. Think about it. We are part of a universe that might have begun with something as unassuming as a quantum fluctuation in a vacuum. Everything we know, planets, stars, even ourselves, could have started from what appears to be nothing. And while we don't yet know everything, each new theory and experiment shows that the vacuum is the foundation of reality. When I look at the night sky, I'm reminded that every star, every planet, and every particle around us exists thanks to subtle processes that begin in this seeming void. The universe is full of surprises, and the vacuum, this invisible dynamic web of energy, is one of the greatest. So now, if someone asks you what nothing is, I hope you smile and say, nothing. It's the foundation of everything. Thank you for making it to the end. I hope I've sparked your curiosity and inspired you. If you enjoyed this video, please give it a thumbs up and subscribe to my channel. Together we'll uncover even more of the universe's mysteries. See you in the next video.